Students, in the previous class we discussed about how to solve a parallel circuit problem using vector method, J method and admittance method, right? So today what we will do is we'll solve one problem using all the three methods, but you people keep in mind, right? So in case of your examination you can solve using any one of the method, right? So which you are familiar with, right? So now we'll take one problem. A parallel circuit problem, right? So here is the problem. A circuit consists of three branches connected in parallel. One branch consists of pure resistance of 10 ohms. The second branch consists of resistance of 20 ohm and an inductance of 0.1 Henry. The third branch consists of resistance of 15 ohm and capacitance of 150 microfarad, right? So all these are connected in parallel. If the circuit is connected across 230 volt 50 Hz supply, then calculate total current, power and power factor, right? So if suppose if these kind of problems asked in your examination, then you need to solve only using any one of the method, but today I am solving this using all the three methods, right? So first take down a method of vectors, right? So for this kind of solutions, what we need to do is we need to calculate all the three vectors, right? So now let us start with the problem. First calculate I1, right? So I1 is what? It is the current flowing through first branch, right? So it consists of only resistor. Then we can directly write I1 is equals to E by R1, 230 divided by 10 ohms, because they are given R1 is equals to 10 ohms. Then we are going to get current as 23 ampere, right? So one more thing is what? It consists of only resistor. Then if it is a pure resistive circuit, then always both current and voltage R will be in phase, right? So now we will go for second branch, right? So second branch consists of what? A resistor and an inductor, resistor of 20 ohm and inductor of 0.1 Henry, right? So as it is an inductor, our job is to calculate XL, which can be written as omega L or 2 pi f L. 2 pi f is 50 and L is 0.1 Henry, right? So if you substitute all that, you will get XL is equals to 31.4 ohms. What is XL? It is inductive reactance, right? So once you get the value of XL and we know the value of R2, isn't it? R2 is how much? 20 ohm. Then we can easily calculate the value of Z2 as under root of R2 square plus XL square. So we are going to get Z2 is equals to 37.23. Now we know the value of Z2, that is impedance of whole branch, and next we know the value of total voltage. Then we can easily calculate the value of I2 as E divided by Z2. Therefore we are going to get it as I2 is equals to 6.18 ampere. Here you can clearly observe, right? So R1 is only 10 ohms, hence the current is more here, but here Z2 is 37.23, hence current is comparatively less, right? So next, as it is a circuit consisting of R and L, we need to calculate magnitude as well as phase. Therefore phi2 is equals to what? Tan inverse of imaginary part divided by real part. Here imaginary part is XL and real part is R2. Therefore it is tan inverse of 31.4 divided by 20, and it is what? 57.5. And one more thing is what? This circuit is consist of inductor. Hence the relation between current and voltage is what? Always the current will be lagging by an angle of phi, right? So here phi is 57.5, therefore it is lagging by an angle of 57.5. Next we will go for third branch, which consists of resistor and capacitor, right? So as it is a capacitor, then our job is to calculate the value of Xc. Xc is equals to 1 divided by omega c, which is nothing but 1 divided by 2 pi f into c. Therefore we are going to get Xc as 21.23 ohms. Once we get the value of Xc and we know the value of R3, then we can easily calculate the value of Z3 as what? Z3 is equals to under root of R3 square plus Xc square. Hence we are going to get Z3 as 26 ohms, right? So again it is a circuit consisting of resistor and capacitor. Then we need to calculate always phase angle, right? So here phase angle phi 3 is equals to tan inverse of imaginary part divided by real part, tan inverse of Xc by R3, that is tan inverse of 21.23 divided by 15, and we are going to get angle as 54.76, right? Again it is what? A circuit consisting of capacitor, therefore always the current will be leading by an angle of phi with respect to voltage. Hence here current is leading by 54.76, and hence we know the value of Z3. We can calculate I3 also. I3 is 230 divided by Z3, so we are going to get 8.85 amperes. Now we can represent this using a vector, right? So vector 1, which is nothing but current I1, it consists of only resistor, hence I1 will be always in phase with voltage because it is pure resistive circuit. Second one is I2, which consists of inductance, hence it will be lagging by an angle of 57.5. Last one is capacitive circuit, hence it will be leading by an angle of phi, where phi is 54.76, right? So this is how we can solve a parallel circuit problem using a vector method, right? Now you can draw the vector like this, or even you can draw the vector taking the magnitude, and you can solve using the graphical method also. That is 23, here you can take 2 centimeter as, or 1 centimeter as 2 volts, then you will be having how much? 11.5 centimeter. Next I2 is 57.5, we will get somewhere here, and last you will get it as I3 54.76. If you join this, then you will get total phase as well as magnitude, which we are going to calculate later. That is summation of x and summation of y, right? So summation of x 23, 8.85 cos 54.76, and last is 6.18 cos 57.5, because all are having positive x-axis, hence I will be having only positive signs. Similarly we go for summation of y. First term is 0 because the vector is lying along a positive x-axis, right? So the second one 8.85, it is positive y-axis, therefore it is plus 8.85 sine 54.76. Last one it is negative y-axis, therefore it will be minus 6.18 sine 57.5. We will get summation of y here. Once we calculated summation of y and summation of x, then we can calculate total current under root of summation of x square plus summation of y square. This will be the total current, and resultant will be what? Tan inverse of summation of y by x, it will be 3.68. You can cross verify this problem using graphical method also, right? So that is, this is your first vector, and second vector, this is last vector. If you draw a line like this, its magnitude should be 31.5 and its phase should be 3.68, right? So if you want, you can solve using graphical method, or you can solve just using a vector method, right? So here they have told us to calculate power factor also, therefore power factor is cos phi. here phi is phi r, therefore cos of 3.68, it is 0.998. Next, power ai cos phi 230 into 31.5 into 0.998, you are going to get it as 7.23 kilowatts or 7230 watts. Right, so if you solve till this much, then the problem will be completed, that using vector method. Right, so if you have any doubts, you can just ping. Right.